this for the position of the vector, velocity of the vector, and the acceleration of the vector, or the position vector, velocity vector, acceleration vector. And then they have the speed of the particle, also known as the magnitude of the velocity vector. So all of those are there. It talks about the length of the arc, but again, we already talked about parametric, so we already have that down, right? Or they use A and B where it should be T equals A and T equals B, so for time, that's what we got going on there. Okay? And the way that these questions are asked are so straightforward and easy. So there's nothing where it's like trying to trick you or anything, so let's go ahead. A particle, this is example 1. I'll make it a little bit bigger for you guys to see. So this is what they say, no calculator. A particle moves in the xy plane so that at any point t, the position of the particle is given by x of t equals whatever, y of t equals whatever, right? Find the velocity vector when t equals 1. Find the velocity vector when t equals 1. So the first thing you have to do is you have to find x prime of t. These are for last period, bro. Sorry, I don't have these kids. Thanks. So you have to find x prime of t and y prime of t, and then plug in the t value that they give you. So let's go ahead and do that. If they give me that x of t is t cubed plus 4t squared, then x prime of t is 3t squared plus 8t. When t is equal to 1, that's 3 times 1 squared, which is 3, plus 8 times 1, which is 8, so 3 plus 8 is 11. So the velocity vector is 11 comma something, whatever the y prime of 1 is equal to. So now we do that. If y of t is t to the 4th minus t to the 3rd, the derivative is 4t cubed minus 3t squared. When t is equal to 1, we have 4 times 1 cubed, which is 4, minus 3 times 1 squared, which is 3. So 4 minus 3 is 1. So my velocity vector, when t is equal to 1, is 11 comma 1. So now let's talk a little bit about what that means. The velocity vector is 11 comma 1. Well, all that means, the fact that dx dt is positive, it means that the particle is moving to the right 11 units per second. Or I think they say second for this. No, they don't even give units of time. So 11 units per whatever the time unit is. So 11 units to the right per one time unit. And it moves 1 unit up per whatever one time unit. So let's just say this were in seconds. It goes to the right at 11 units per second and up 1 unit per second. So it's moving further and faster to the right than it is up. Make sense? If you wanted to write that or just draw the vector, it would be over 11, up 1, and it'd be that way, and that's the velocity vector. And then it says, find the acceleration vector when t is equal to 2. Well, again, we already found x prime of t and y prime of t, so we're just going to take their derivatives with respect to t to find x double prime of t and y double prime of t, and then plug in 1 for those, and they get that, or sorry, not 1, 2 in this case, because they said when t is equal to 2. So a of 2 is equal to 20 comma 36. So let's talk about the meaning of that. What does it mean that the x position, or this particle, in terms of the x position, is accelerating at 20? That means that it is what? speeding up, acceleration, positive, right? The x position is when t is equal to 1, the x position starts off at, or when x equals, or t equals 2, whatever. It's positive, and the, you know that the velocity is positive, and the acceleration is positive. So the velocity was 11. I guess this is two different t values, sorry. But anyway, at t, you have that the acceleration for the x values is positive, right? So it's going to the right faster. You also have that the acceleration of the y values is positive, meaning that it's going up faster, right? So that's what we have going on there. So sometimes they'll say find the magnitude of the velocity vector. Magnitude of the velocity vector is just known as speed. So that's the square root of, x prime of t squared plus y prime of t squared. So in this one, all that you're doing is finding the magnitude of the velocity vector, which is just the speed of the particle at the given time value. And so they say when t is equal to 1, so that's just going to be the square root of 34. So that's the speed of the particle. Okay? That's really kind of it. They go through other examples on here, but that's it. Then they just have you do the homework, and this is what you're going to be doing tonight for homework, is day 4 homework.